It is generally not accepted practice to replace 3-prong grounded outlets with 2-prong ungrounded outlets in the United States. Here's why. The National Electrical Code, NEC, requires that all new and replacement receptacles in homes and businesses be grounded. Grounding provides a safe path for excess electricity to flow back to the ground, reducing the risk of electrical shocks and fires. Ungrounded outlets can pose a significant safety hazard. If a device connected to an ungrounded outlet malfunctions, it can create a dangerous electrical path through the device's user or nearby objects. Many modern appliances and electronics require a grounded outlet for proper operation and safety. Plugging these devices into ungrounded outlets can damage them and void their warranties. Home inspectors are likely to flag any ungrounded outlets as potential safety hazards. This can result in a failed home inspection, which can delay or prevent the sale of the property. In some jurisdictions, it may be illegal to replace grounded outlets with ungrounded ones. If an electrical accident occurs due to an ungrounded outlet, the homeowner or electrician could face legal liability. While it may have been common decades ago to replace grounded outlets with ungrounded ones, it is no longer considered an acceptable practice due to safety concerns, code requirements, and potential legal implications. It is recommended that you reinstall 3-prong grounded outlets, which will ensure the electrical safety of the home and pass a home inspection. Grounding is a critical safety feature in electrical systems. It provides a low resistance path for fault current to flow back to the source, tripping a circuit breaker or fuse and cutting off power to the circuit. This prevents dangerous voltage from building up on metal parts of appliances or equipment, which could cause an electric shock if someone touches them. In a properly grounded system, if a fault occurs, the high fault current will quickly trip the overcurrent protection device, such as a circuit breaker or fuse, isolating the faulty circuit and preventing further damage or injury. Ungrounded electrical systems lack this safety feature. If a fault occurs in an ungrounded system, the fault current may not be high enough to trip a circuit breaker or fuse. This can result in a dangerous voltage buildup on metal parts of appliances or equipment, creating a shock hazard. Additionally, ungrounded systems are more susceptible to voltage surges and spikes, which can damage sensitive electronic equipment. The National Electrical Code, NEC, is a comprehensive set of standards for electrical wiring and equipment in the United States. It is updated every 3 years to reflect the latest advances in electrical safety and technology. The NEC covers a wide range of topics, including grounding, wiring methods, overcurrent protection, and equipment installation. It is essential for electricians and other electrical professionals to be familiar with the NEC to ensure that electrical systems are installed and maintained safely. When replacing receptacles, it is important to follow the NEC guidelines for grounding. If the existing wiring system does not include a grounding conductor, there are several options available. Firstly, you could install a new circuit with a grounding conductor. This is the preferred option as it provides the highest level of safety. Secondly, you could install a ground fault circuit interrupter, GFCI receptacle. A GFCI receptacle is designed to protect against electric shock by detecting ground faults and quickly cutting off power to the circuit. While a GFCI receptacle does not provide a true ground, it can provide a significant level of protection in ungrounded systems. Thirdly, you can install a 2-prong receptacle if it is a like-for-like replacement. This method should only be used when other options are not possible because it provides no grounding protection. It is important to consult with a qualified electrician to determine the best option for your specific situation. It is also important to note that some jurisdictions may have additional requirements for grounding electrical systems. It is always best to check with your local building department to ensure that you are complying with all applicable codes and regulations. The dangers of ungrounded outlets extend beyond the immediate risk of electric shock. They can also contribute to other electrical hazards, such as fires. When an electrical fault occurs in an ungrounded system, the fault current can flow through unintended paths, such as metal pipes for building structures. This can cause these materials to heat up, potentially igniting nearby combustible materials. In addition to the safety hazards, ungrounded outlets can also damage sensitive electronic equipment. Many modern electronic devices, such as computers and televisions, rely on a stable ground connection to operate properly. Without a ground connection, these devices are more susceptible to voltage surges and spikes, which can damage their internal components. This can lead to premature failure of the equipment and costly repairs. From a legal standpoint, it is important to be aware of the potential liability associated with ungrounded outlets. If someone is injured or property is damaged as a result of an ungrounded outlet, the homeowner or electrician could be held liable. This could result in significant financial losses, including medical expenses, lost wages, and property damage. In some cases, it could even lead to criminal charges. Therefore, it is essential to take the necessary steps to ensure that all electrical outlets are properly grounded to protect yourself from potential liability. When selling a home, it is important to disclose any known electrical hazards, including ungrounded outlets. Failure to do so could result in legal action from the buyer. Home inspectors are trained to identify potential safety hazards, including ungrounded outlets. If a home inspection reveals that there are ungrounded outlets, the buyer may request that they be repaired or replaced before closing the deal. This could delay or even prevent the sale of the property. Therefore, it is best to address any electrical issues before putting your home on the market. In conclusion, replacing 3-prong grounded outlets with 2-prong ungrounded outlets is not an acceptable practice. It poses a significant safety hazard, violates the National Electrical Code, and can lead to legal liability. It is always best to consult with a qualified electrician to ensure that your electrical system is safe and up to code. Doing so will protect you and your family from potential electrical hazards and ensure that your home meets all applicable safety standards. Furthermore, upgrading to grounded outlets can increase the value of your home and make it more attractive to potential buyers. It is an investment that will pay off in the long run. When working with electricity, it is always important to exercise caution and follow all safety precautions. Electricity is a powerful force that can cause serious injury or death if not handled properly. Always turn off the power before working on any electrical circuit. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the job. They have the knowledge and experience to safely and effectively handle any electrical task. In addition to grounding, there are other important safety features that should be included in an electrical system. These include arc fault circuit interrupters, have size, and surge protectors. Size are designed to protect against electrical fires by detecting arc faults, which are dangerous electrical discharges that can occur when wires are damaged or insulation is worn. Surge protectors are designed to protect electronic equipment from voltage surges and spikes. These devices can help to prevent damage to sensitive electronics and extend their lifespan. When planning an electrical project, it is important to consider all of these safety features to ensure that your electrical system is as safe as possible. It is also important to have your electrical system inspected regularly by a qualified electrician. This will help to identify any potential problems before they become serious hazards. A qualified electrician can also perform routine maintenance, such as tightening connections and replacing worn components to keep your electrical system in good working order. By taking these steps, you can help to ensure the safety and reliability of your electrical system for years to come. Knob and tube wiring is an outdated wiring method that was commonly used in homes built before the 1940s. It consists of single insulated wires run through ceramic knobs and tubes to support and protect the wires. Knob and tube wiring lacks a grounding conductor and is often deteriorated due to age and exposure to the elements. If you have knob and tube wiring in your home, it is important to have it inspected by a qualified electrician. They can assess the condition of the wiring and recommend appropriate steps to improve its safety. In some cases, it may be necessary to replace the knob and tube wiring with a modern wiring system. This can be a costly project, but it is well worth the investment to protect your home and family from electrical hazards. When replacing knob and tube wiring, it is important to use a wiring method that includes a grounding conductor. This will provide a safe path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shocks and fires. There are several modern wiring methods that can be used to replace knob and tube wiring, including non-metallic sheath cable, NM cable, an armored cable, AC cable. NM cable is the most common type of wiring used in residential construction. It consists of 2 or more insulated wires wrapped in a plastic sheath. AC cable consists of insulated wires wrapped in a flexible metal sheath. Both NM cable and AC cable include a grounding conductor. When installing new wiring, it is important to follow the National Electrical Code guidelines for wiring methods and grounding. This will ensure that the wiring is installed safely and correctly. It is also important to use the correct size of wire for the circuit. The size of the wire depends on the amount of current that the circuit will carry. Using too small of a wire can cause the wire to overheat and potentially start a fire. The National Electrical Code provides tables that specify the appropriate wire size for different circuit ratings. It is important to consult these tables to ensure that you are using the correct size of wire. In addition to wire size, it is also important to use the correct type of overcurrent protection device for the circuit. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the circuit from overloads and short circuits. When an overload or short circuit occurs, the overcurrent protection device will trip, cutting off power to the circuit and preventing damage to the wiring and equipment. It is important to use an overcurrent protection device that is rated for the circuit's amperage. Using an overcurrent protection device that is too large can allow the circuit to become overloaded, potentially causing a fire. The National Electrical Code provides guidelines for selecting the appropriate overcurrent protection device for different circuits. It is important to consult these guidelines to ensure that you are using the correct overcurrent protection device. Electrical safety is a critical aspect of home ownership. By taking the necessary steps to ensure that your electrical system is safe and up to code, you can protect yourself and your family from potential electrical hazards. It is always best to consult with a qualified electrician to discuss any electrical concerns that you may have. They can provide expert advice and guidance to help you make informed decisions about your electrical system.